All right. Let's see. So we've got the period of this thing. We've got the length of the rod. We've got the mass here. So I think this is one of these ones where we're going to figure out the weight of it and we can figure out the centripetal acceleration. So the weight is 1.8 times 9.81. We need this because we got to solve F equals ma, right? So 1.8 times 9.81 is 17.658. And then the centripetal acceleration is 4 pi squared over t squared. And I'm going to choose that one because I'm given the period, right? So that's 4 pi squared times 3.8 divided by 3.3 squared. All right, so here we go. Let's figure that out. I'm going to store that in the weight, and then I'm going to go 4 times pi squared times r divided by t squared, so 3.3 divided by 3.3 squared. If we get to square the t, oh, this is fun. 13.776 is what I'll say. Now notice that this acceleration is bigger than g, so at the top we'll be pulling down, right? That's why it's a negative thing. At the bottom, of course, you always pull up on it. Okay, so let's see. So we want to figure out the force of the rod at the bottom and the top, right? Okay, so let's draw a picture of this guy. Where do I draw it? Here. Okay. Okay, so at the top we've got some unknown force, right? The force of gravity is acting down on it, so that's our 17.658, right? And our acceleration when we're at the top is going to be this, but it's going to be down because it's toward the center, right? So at the top we've got some unknown force minus 17.658, and then that equals 1.8 times this guy, but negative, right? Okay, so again, why is that negative, right? It's negative because at the top here, we're accelerating toward the center. The center is below us, so therefore we have to accelerate down, okay? That's why it's minus. And that's really the only difference between the top and the bottom. We're going to set up the same thing at the bottom, and we're going to make that positive. Okay, so here we go. Now let's store that in A. And so I'm going to go 1.8 times negative A. Okay, and then I'm going to add this plus the weight. And I get that that force is negative 7.138 or something like that. So negative 7.14 newtons. This would be, of course, a downward force. And you do need to say that. I need you to say what it is. It's not enough to just say negative. Say that it's down. Okay. At the bottom, okay, we're going to be accelerating toward the center, but now the center is above us, so our acceleration is positive, right? So we set the same thing up. We still have gravity acting down on us, 17.658. Right, so we go force minus gravity, 17.658. And that equals 1.8 times, and then we just go positive 13.776. Yeah. Okay, so now I'm going to go this, 1.8 times A, because I stored this value in A. Okay, and then I'm going to add that plus W. I'm getting 42.45 and some change. So 42.5. Right, since it's positive, it's definitely up. I need you to say that. Say that it's up. Yeah? Yeah, yeah?